Hello there, hi, it's Jamie here from Cadtek Systems. I'm just going to take the next 30 minutes or so just to go through a demonstration that I've prepared, just showing you how SolidWorks can be used and is being used within the point of sale industry. The kind of design, the product that I'm going to get involved with is what you see on the left hand side there. So this is just a really simple stand to hold cans of Coke. I've broken it down into 4 sections. First of all, we're going to be looking at the basic modeling, so how we can actually create the geometry that you see on the left, and also the technical drawing that goes alongside it. Also, then we can do some virtual testing, so I can actually apply loads to those shelves just to see if it's going to fail or if it's going to flex too much and things like that. So I don't really want to have to go and make it first and then test it. I want to virtually test it before making it. We can also look at sustainability. So there's a utility in SolidWorks that allows us to evaluate the environmental impact and the carbon footprint of our designs, and we can actually ask SolidWorks to give us suggestions on other materials that might be more suitable and more environmentally friendly. And then we're going to finish with some rendered images, so we're actually going to go ahead and create the image that you see there on the left hand side. Okay, so first of all, we're just going to look at basic modeling and our technical drawing. So the first thing we're going to do is just to draw a side view, if you like, of our back panel. So you can see I've got some dimensions there. That's what we're going to do. We're going to draw that sketch. Then we're just going to give it a material thickness and also say how wide we want it. And we create our back panel. Then we're just going to create a shelf onto that back panel. We're going to create another duplicate shelf above it, so we don't have to do that again from scratch. We can actually create what we call a linear pattern of that particular shelf. And then we're just going to soften some of those hard edges with some nice radiuses in the corner there. And then to finish with, we're just going to then create our technical drawing, so our 2D technical drawing for manufacture. And that shouldn't take more than about 5 minutes or so. So let's have a look at how we do that. So over in SolidWorks, I'm just going to start a brand new document. So you can see here I've got some templates. We've got some 3 basic types of template. We've got a part template here, which is just a single part, but that can be made up out of multiple bodies. That's using what we call multi-body design, and I'm going to be using that today to design my product. Then we've got an assembly template, which is just a collection of parts and or sub-assemblies, and then we've got a drawing template. You can see I've got 2 here. One's just A2 and one's A3. So I'm just going to double-click part, and that takes me into the part environment. First thing I'm going to do is just to highlight these 3 work planes for you. This is the generic kind of top, right and front plane that comes with all the templates. And I'm actually going to take my right plane over here and I'm just going to drop a sketch onto it. Now all of my sketch tools are up here. This is what we call a tabulated toolbar basically. It means we can switch between different tool sets. There are hundreds of tools in SolidWorks and to save having them all available out on show, we can actually create tabs up here to make sure that we have our maximized workspace, which is this bit down here. So you can see that all of my sketch tools are up here. Now I actually prefer to get to my sketch tools wherever I am. If I'm working down here, for example, I just hold my right hand mouse button down, sweep right, and this brings up my shortcut bar. So it just means wherever I am, I can bring up this shortcut bar. So if at any point you're wondering, where on earth has he just got that toolbar from? That's all I've done. It's just a right hand mouse button and sweep right. And you can configure that to be any controls that you like. So the first thing I'm going to do is just to pick up a line tool. And I'm just going to draw roughly the shape of my back panel. Now if you guys are using AutoCAD, you know that you can't do this before kind of specifying lengths of lines and things. I always describe this as sketching with a pencil. I actually don't have a development book anymore. I do all of my development in SolidWorks. I don't think there's much point in actually doing it twice. So you can see how I've sketched it, roughly the proportions I'm after. All I need to do now is to come in here with some ink, if you like, my Smart Dimension tool, and start inking up over my pencil drawings. So all I'm going to do is specify some dimensions. So we're going to say that the base panel or the base plate of my back panel is 165 deep. Let's maybe go for an angle here. You can see that my one dimension tool is doing everything from lines to angles to diameters to radiuses. I don't have 5 or 6 tools like again we do in AutoCAD. We'll call it any other CAD from now on, I guess. So I'm just going to go for an angle of 30. Then I'm just going to say there's an overhang here of about 20. And then finally I just want to have a total height of say 500 for my unit. And that's my sketch done. All I need to do now is just to turn it into sheet metal. So first of all, this is my sheet metal dialog box over here. I'm just going to specify the thickness. We're going to do this in 1.5mm thick. I'm just going to say which direction I want it to go in. I'm actually going to do what we call a mid-plane extrusion. So I'm coming both ways out of that center plane. And we're going to have that to a total depth of, let's go for 255. And also I just need to specify which side of the line I want my material to be on. You can see here that my 1.5mm thick, I can have it on the inside or outside. So I'm just going to say I'm going to have it on the inside of that. And that's my first bit of geometry created. So that's my back panel. Next thing I want to do is to draw my shelf. So I'm just going to draw the profile of the shelf, or like a section view of the shelf, onto this surface here. So I'm just selecting the surface, I'm saying sketch, and now I'm sketching straight down on there. Again, I'm just using some regular tools that you guys are going to be familiar with, lines and center lines and arcs, circles, polygons, that kind of thing. We've got all of those as well. So I'm just going to use what we call a center rectangle, just to mean that it's centered around that point, as you can see here, because we've got some symmetry, some form of symmetry that we're going to utilize. Then I'm just going to specify some dimensions. So my total depth of shelf is going to be 20mm. I'm just going to say that I want it to be 10mm from where that fold is, and also 10mm out to the side as well, or 10mm offset from the side. And then just going to select this line and tell SolidWorks to turn it into construction geometry. So basically SolidWorks ignores it. It won't build from dotted lines, it'll only build from solid lines. So hopefully you can see that we've got 3 solid lines here. It's like an upside down hat. Then all I'm going to do is extrude that as well. So again, using sheet metal, I'm going to say that perhaps we want it to be 140 deep. Again, I can specify which side of that line my material is. You can see here I can toggle between inside and outside. We're going to go for inside, and then I can accept it, and that's created our next piece of sheet metal. What I want to do is to turn up the front of this shelf. So I'm just going to use what we call an edge flange. So I'm using sheet metal in SolidWorks. This is a utility, a great utility for creating sheet metal parts. So first of all, I'm just going to drop it around there somewhere. I'm actually just going to say that I want it to end on this vertex here, right on the end. And then that just means that if that vertex changes, or if it moves, then my edge flange is always going to go up to that as well. And this is what we call parametric modeling. So I'm building things in relation to other things. So then I'm just going to accept it. And I'm going to build another one on the back. So I'm just going to turn up the back as well. So again, I'm just going to drop it up here. But I'm going to give a depth to this one. So I'm going to say that I want a 10mm return on the back of there, something like that. Now you can see at the moment this is just kind of stuck on. Well, I'm not going to weld this, I'm actually going to tab it in there. So I'm going to put little ears on this shelf, and I'm going to put slots in this back panel. So the first thing I'm going to do is just to drop an ear on the side of that shelf. And again, using a line tool, I can come in here and I can just draw my little ear or my tab, something like that. And you can see that although dimensions are being called out, so at the moment 6.2 that line is, I'm not really paying too much attention to it, because as I said, you know, I can move this around and shape it as I wish or get the proportions right, but then I can come in here and actually drop on some dimensions. So the first thing I'm going to say is this top section is going to be 8mm. I'm going to go for a distance between the slot and the back of the back panel of 1mm. The back of the tab is going to be 5mm with a total height of 16mm. So I need to remember that for later when I'm dropping my slot in. So 16mm, the total depth of that tab. And then all I'm going to do is just to basically bond it to that particular shelf. And that then becomes a part of it. Now you can see that we haven't got a hard edge down here. This is basically because it's interfering. So this is currently going through here. So I need to create some slots. But first of all, I'm just going to drop a tab onto the other side as well. Now I've got a right plane, because if you remember I dropped my very first sketch on my right plane and did a mid-plane extrusion. My right plane sits in the very center of my part. So I can actually use that to mirror across that last tab that I've just done. So using a simple mirror technique, you can see now that we've got 2 ears. So if you've got any form of symmetry in your designs, then we can actually get away with just designing kind of half of it if you like. Next thing I'm going to do is just to sketch onto my back panel and actually create my slot. So first of all, coming in here, I'm just going to change my display so that it's a wireframe so I can see what's going on. Then I'm just going to draw a little center line to help me out, so I can use a center rectangle. The bottom of that center rectangle I want to be coincident with the bottom of my slot. So I'm just going to say that's a collinear relation, so we can actually add relations to things. My total slot length is going to be 18mm. So that's my 16mm of my tab plus a couple of mil clearance. And then I'm just going to build a relation from the outside of my shelf to the inside of my slot of 0.5mm. And because I've used a center rectangle there, we've got 0.5mm on both sides. It just means I don't need to dimension this one over here. That's automatically done for me. Now I want a slot to be on the other side as well. It's going to take me a couple of minutes to do that if I do it from scratch again. So I'm just going to draw a little center line. Now a center line I can actually use to mirror things around. So if I just select these 4 edges of my rectangle and my center line down here, I can use what we call a mirror command just to drop it on the other side as well. And then I'm just going to go ahead and cut. I'm just going to say that I want to cut through everything, but actually only just this back panel here. Now if I just change the orientation or change the view, you can see here that we've now got what we're after. Next thing I want to do is just to drop some holes. Now there's a badge that's going to go here, a Coca-Cola badge, and it's got two little kind of pips on the back of it, if you like. So onto this, I'm just going to draw some holes for it. The first thing I'm going to do is just to draw a center line. Again, this is going to help me to locate the center. Then I'm just going to use, this is a relatively new tool called a midpoint line. It just allows me to do something like that. I'm going to draw two circles. I'm just going to tell SolidWorks that these two circles are equal. That means if I change one, the other changes as well. And then I'm just going to dimension, the distance between them is going to be 1 inch, and the diameter is going to be 3.5. And again, I'm just going to tell SolidWorks that line in the center there, I want to ignore it. So then when I do a cut, it just uses those two circles. I'm just going to say I want to cut up to the next thing it sees, which is the back of this shelf here. Okay, then I want to create another shelf. This has got two layers of cans of Coke. So instead of me doing all of that again, I can actually use what we call a linear pattern. So first of all, I'm just going to pick up the tool. So you can see I've got all of the tools that I need at my fingertips. I'm not having to search through bucketfuls of tools to find them, which is great. I'm just going to select this edge as a reference. Hopefully down here you can see there's a little arrow. It's pointing down at the moment. Now that's incorrect. I need it to point up. So I'm just going to click on this button. That flips it to point upwards. And then I'm just going to say that I want to copy that body, and I want the distance between them, so the shelf pitch in effect, to be 170. And now I've got two shelves. Really, really simple. I also need two slots as well. So let's just do that too. I'm going to use the linear command button again. So I'm just going to specify the edge. And this time I want to pattern this particular cut feature here. And I only want it to cut out of that back panel. So you can see now that we've got two slots on the top there. And then to finish this design off, I'm just going to select this corner and add a fillet. I'm just going to go for quite a generous one, go for an inch radius. So let's just pick up on some of these other small edges as well. So this one in the corner, and then finally this one as well. And you can see now that that's my design finished. So the first thing I'm going to do is just to tell SolidWorks what material it is. Now this is standard SolidWorks, basic cheapest level SolidWorks, comes with all of these databases full of numbers and full of decent materials that I can use. You can see here that we've got a good selection of steels. We've got lots and lots of aluminium alloys, for example, and plastics and timbers and all kinds of lovely things. So I'm just going to dip into steel. We're going to go for plain carbon steel. This is just like a mild steel, if you like, and then I'm going to apply it. But before I do, I just want to show you that in our database here, we've actually got a series of numbers that we can use. So, for example, the mass density, that's going to allow SolidWorks to evaluate the weight of this product. But also we've got things like elastic modulus, Poisson's ratio, shear modulus, and that's going to allow SolidWorks to evaluate and do stress testing on it. So let's just apply that material. Now I want it to look like a nice colour for the cans of Coke, so I'm just going to go, I'm going to want this to look painted. So the material is plain carbon steel, but I'm actually going to paint it with car paint. So that's like ultra high gloss, lovely red paint, so that when we do a render later on it's going to look lovely. So next thing I want to do is to create a 2D technical drawing of this. So my manufacturer wants to understand what the information he needs. In fact, talking about the manufacturer, let's just have a look at this back panel, for example. I can flatten that, and that's the flat pattern needed. So if you guys are spending money on having your sheet metal parts flattened by your sheet metal guy, then no longer do you have to do that. So we can actually do that ourselves. And also there's our flat pattern of our shelf. So really, really nice that we can create that kind of information. Okay, so going back to the 2D technical drawing, I'm just going to save this onto my desktop just so I know where it is. We'll call this Coke stand. Down here we're just going to give it a drawing number, so maybe this is for Coca-Cola. And I'm going to create an A3 drawing of it. Now this is where SolidWorks comes into its own really, because we apply all of our efforts, if you like, to the 3D CAD model, and the drawing is also almost kind of going to do itself. So over here we've got some predefined views. As you can see, we've got our front and right and top planes and things like that, those kind of views. I'm going to take my front view of this particular part, a side view, a top view, we'll have an isometric view over here. First thing I'm going to do is just to change the scale. So I wouldn't mind those views being a little bit bigger, so I can do that here. We'll say 1 to 4. We can also ask SolidWorks to fully dimension this technical drawing for me as well. I'm just going to shade that view over here. I'm going to ask SolidWorks to fully dimension this technical drawing because I could do this on my own manually, but in fact I've already done it in the 3D model. So all I'm asking SolidWorks to do here is to bring across those dimensions from my 3D model into my 2D technical drawing. Now SolidWorks has fully dimensioned this for us. You can see there's a few dimensions here that I might not want to have, so I can delete them, and you can see how easy it is just to move dimensions around as well. So if you deem that nowadays certainly if I'm giving a metal basher or a sheet metal guy a technical drawing, I generally just give them the DXF file and you can work from that. I just put a couple of dimensions on there just to give them an idea of the scale. But again, you can see how easy it is just to kind of move things around and place them wherever we want to. Also, we can do things like detail views and add detail views as well really quickly. So maybe a detail view of that little tab over here, and we'll just add a leader on there, just give it a full outline as well. And again, I can change the scale of that if I wanted to say 1 to 1. Okay, so that's my technical drawing complete. And also if I look down here, this has filled itself out too, my title block. So it's telling me the material that I'm using, who I am, today's date, the materials, the descriptions I've added, and the current weight of this part as well. So at the moment, that weighs 3.2 kilos. So it's a really nice way of being able to ascertain the weight of this particular design. I can then also save this if I want to give this to somebody who hasn't got SolidWorks. I guess I could do what I could save as a PDF. I could save it as a DXF if I wanted to. Now this is an e-drawing. E-drawings is completely free. It doesn't cost anything to have e-drawings. But what it allows you to do is to actually communicate in a far better way. I.e., I can write on this if I want to using some markups. I can stamp it. I've got a series of stamps here. I can actually take measurements from this as well. Now you can disable that function. So if you want to protect IP, for example, you don't want people to be able to measure from your technical drawings, then you can disable that function. But what we've actually got there is not just a 2D technical drawing. We've got a 3D model that we can spin around, rotate around, do sections through. So it's a great way of being able to communicate because not everybody can understand 2D technical drawings. So it's just a cracking way of being able to communicate in 3D because we think in 3D. So it's a really powerful way of being able to communicate. Okay, so let's just now have a look at something else. Let's just go back over to our PowerPoint. So that's having a look at the basic modeling and the technical drawing. So the next thing I want to do is to virtually test my design. So I want to make sure that it's actually going to stand up to reality, and if we put cans of Coke on it, it's not going to flex too much or it's not going to break or anything like that. So all we need to do with FEA is really simple. I want to find out, is my design safe? If it's not safe, is it going to fail and where is it going to fail? Also, what is the factor of safety? So how many times the loading could I add before it actually does fail? So i.e., for general consumer products, I guess you're looking at a factor of safety of between something like 3 and 6. So you could expect to apply between 3 and 6 times the load that it might have to in reality before it's going to fail. Obviously things like, I don't know, motorsport and things like that, that's generally low factors of safety because they want it, as the old adage that they want it to fail as soon as it goes over the finish line. Well, that's a low factor of safety there. And also, does the design flex? Does it move? And if it does, how much does it move by? So if those shelves are deflecting, how much is the deflection and what is it? So first of all, let's just have a look at our loading. We've got 6 cans of Coke, each of them weighing 390 grams. We've got that spread across 2 shelves as well, so we've got 6 cans on each shelf, which is a total weight of 4,680 grams or 4.68 kilos. Now that in newtons is 45.9 newtons, and we're going to apply the force in newtons. Now we could apply it in kilos if we wanted to, but I'm going to apply it in newtons, which is equal to 45.9 newtons. So that's spread across the 2 shelves. It couldn't be easier. When people think about FEA, they think it's really difficult. All we're going to do is take our load and we're going to apply that load to both of those shelves. So that load of 45.9 spread over those 2 shelves. Then we're going to add a restraint, and we're going to basically fix the base to the floor. And what that's going to give is some really lovely pictures, lovely colours, things like that obviously, but some decent kind of engineering data and to ascertain whether this thing's going to pass or fail. So let's have a look at how we do that. Okay, so the first thing I'm going to do is just to set up my simulation study. So over here I've got my simulation tab. I'm going to create a new study, just a static study. And I need to do two things, remember. I need to fix it and I need to load it. First of all, I'm just going to make sure that I've got my plain carbon steel material applied to all of my bodies or all of my particular parts in this assembly. Then I'm just going to add some restraints. So the restraint I'm going to add is just a fixed base, so the base can't move. And then I want to apply a load, which is going to be a force, but I can apply a torque if I want to. I'm going to apply a load to these two shelves with a total of 45.9 newtons, and that's not per item, that's just total, so overall 45.9, so it's going to divide it between those two shelves there. And then I can click OK, and then I can run my study. Now, gone are the days where you'd do an FEA study and you'd kind of hit the run button, you'd go home, and the next day you'd come in, and if you're lucky, you've got some results. You can see it's done it already. It does it very, very quickly. So also what you probably the first thing you notice is that it's bent. It's very, very bent. Now, this is actually applied, or SolidWorks has applied a deformation scale there of 28 times. That is purely for me to see, is it deflecting or moving in the right way? I think if it was kind of bending backwards or bending over or twisting to the side, I know that I've got something wrong in my setup. So that's just a really nice way of being able to ascertain whether I've got my loads and my restraints in the correct place. Now over here we've got our scale. So we're looking at the von Mises scale at the moment. And you can see the red areas are the high areas of stress. So the high areas of stress really are in these kind of areas here where my tabs go in to the bottom. And also there might be some stressing, I think, probably in these bends as well. Now that doesn't really tell me anything. It's certainly told me that it hasn't yielded or it hasn't failed. Otherwise this red arrow here would be pointing to the scale at what point it had failed. So we know that it hasn't failed. We can also look at displacement. Now if I just change this to a number that we can all read, the red section there, the darkest section, is actually moving by 1.8 mil. And if I just change this to 1:1 scale, I can actually animate that as well. So this is like me applying the load back and forth, putting the load on, taking the load back off again. So you can see it is deflecting, it is budging ever so slightly. But again, that's not really telling me too much. The important thing is, what's the factor of safety? So coming over here, I can just ask SolidWorks to tell me what the factor of safety is. And at the moment it's 1.5. So basically I could apply 1.5 times my expected load before it starts to fail. Now that's probably not that good. So I need to make some changes. So again, couldn't be easier in SolidWorks. Remember, I'm doing all of this in the SolidWorks interface. I'm not having to leave it to go over to a separate FEA package. I'm doing it all in SolidWorks. So I'm just going to go back over to the model. I'm going to take my first feature that I created, that back panel, and I'm just going to change it to say 3 mil instead. So now I'm using a 3 mil back panel. I come back over to my study, I rerun it. So what we're going to do is just come back over to that study, rerun the study. Again, it only takes a matter of seconds. The displacement, is it moving by much? Well, actually look now, it's only moving by 0.2 millimeters. So a lot of the flex, all of the flex was in this kind of bottom fold here, or this fold here. So we're only getting a very small deflection now. And also the factor of safety has increased to 4.8. So I think we're going along the right lines. If I wanted to bring that down, I guess I could change this back panel to something like 2 mil, I guess. Okay, so from there what I can do is I can actually generate a report. Now again, gone are the days where I'd have to do this manually. You know, I might open up Word, I might take screenshots, I might paste those into Word, I might take some of my results and try and tabulate them nicely or make them look pretty in Excel. Again, maybe switch that over to my Word document, apply company logos, things like that. Well, hopefully what you can see there is SolidWorks is doing exactly the same for me. It does it very, very quickly, and in a matter of moments, we've got our Word document. So if I just spread this across a couple of pages, SolidWorks has actually gone ahead and created for me a 12-page report based on that simulation study that I've just done. So if you need to prove to people that your designs are going to work, maybe showing the boss what you've been doing for the last, I don't know, say half an hour or whatever, then that's how you can do it. So it's a really nice way of being able to document your simulation studies. Okay, so let's just switch back over to our PowerPoint. So we just had a look at how to do the testing of our parts. So using FEA, we can actually virtually test our parts. Now let's have a look at sustainability. So this allows, or this is a utility in SolidWorks that allows us to evaluate the environmental impact and carbon footprint of our design. So we're going to take just a simple component, maybe a badge or something. This is an injection molding for our Coca-Cola thing. This is going to kind of clip onto the front of our sheet metal shelving. And we can ask SolidWorks to basically evaluate the environmental impact, but also to see if it can find different materials that might be more suitable. So let's have a look at how we do that. So first thing I'm going to do, I'm just going to open up the part itself that I'm after. So in one of my libraries here, I'm just going to open up the Coke logo. So this is my badge. You can see there's a couple of little pips on the back. And at the moment, it's in polystyrene high impact over here. The material is set at polystyrene high impact. Fairly common material in, I guess, point of sale in general, but it's fairly cheap. It's relatively strong. It does the job. It's kind of, I guess, my first port of call is usually, we'll do it in polystyrene here at high impact. But is there a more suitable material that might be better for the environment and also potentially cheaper as well? So let's have a quick look. So we're going to use sustainability to look at this. So the first thing we're going to do is just to set the type of material. So it's a plastic, it's polystyrene, high impact. Down here we specify where it's going to be made. So I'm saying that it's made in Asia. So perhaps it's made in China, somewhere like that. It's built to last a couple of years. It's using the injection molding process, which these are typical values for the injection molding process. And then down here we can specify paint as well. So I've said it's a no paint finish. Where it's used, so I'm just going to say that it's being used in Europe. So by default it says that it's being shipped by boat that distance there, so 16,000 plus kilometers. I can transport it by plane if I want to instead, or road or rail as well. So these are things that I can change if I'm maybe just doing it in Europe. And also the end of life. What do I expect the percentage to be recycled, incinerated and put into landfill? So you can see here then that we've got different numbers. This is currently what we're looking at. So this is some of the numbers that we are currently looking at using polystyrene high impact. First thing I'm going to do is just to set this as what we call a baseline, because I want to have a look to see if any other materials can come better than that or match that. So back up here, I can ask SolidWorks to find a similar material. I'm just going to make this window a little bit bigger. And first of all, I'm just going to say that the material class, I want to look at plastics. So I want SolidWorks just to evaluate plastics for this. And here are then a series of properties and conditions. So the material properties are here, i.e. do I want it to be less dense or more dense? Do I want it to be cheaper or more expensive? And here then is the condition. So I just say basically greater than, less than or equal to. So first of all, I'm just going to say that, for example, elastic modulus, I'm not really too bothered about that, so I'm going to leave that at any. Also thermal expansion, I'm going to leave that at any as well. Mass density, I'm going to change this to see if I can find ones that are less than. So that's like a backwards arrow there. I'm looking for materials now that are less dense than our current part. But obviously I don't want the strength to be affected. So I'm just going to say that I want it to be stronger than the polystyrene high impact. So I'm looking at a lower density, so it's going to weigh less, but also I want it to be stronger. So let's just have a look. So here are the materials then that SolidWorks has found that kind of fit in with my criteria there. If I just select one, we'll go for ABS to begin with, fairly common. ABS material. Down here you can see what it's doing. It's looking at the carbon footprint, so the carbon that it's using. If I choose to use ABS now in place of polystyrene high impact, then there's a 17% increase in carbon. There is a 5% increase in energy used, 1% increase in air pollution, and a 23%, almost a quarter more water eutrophication. And also there's a small financial impact there of 0.5%, so it's not that much more expensive, but certainly it's not any better for the environment. In fact, it's worse. So you can see basically the red bars are bad. So let's have a look at the ABS polycarbonate blend, for example. You can see that. So again, the ABS polycarbonate blend, that's not so good either. Let's have a look down here. The PP copolymers, that's a polyprop. Okay, well this is interesting because you can see that we've actually got decreases now all the way across the board. So it's 23% less carbon, 18% less energy used, 20% less air pollution, 24% less water eutrophication, and also there's a 17% reduction in the financial impact as well. So it's almost a quarter cheaper. We'll have a look at PPE. Okay, so PPE is not so good. The homopolymer, Fairly similar to the copolymer, not quite as good there, only a 16% financial impact as well. But yeah, it's not quite as good there as the copolymer. And maybe we could look at a polyprop film or a medium high impact polystyrene. So again, we're getting some, I mean, there's a lot of decent materials there that we could use that are better for the environment, but also cheaper as well. Now, I think the best one was the copolymer, so the PP copolymer. So I'm just going to accept that material, and you can see over here it's updated our baseline. And what I can actually do is generate a report on that as well. So if I just generate a quick report. Again, SolidWorks is doing all of this for me. I don't have to now try and maybe take screen dumps and things like that and drop them onto a Word document. SolidWorks is actually going to go ahead and do this for me. And here we go. Here's my sustainability report. Again, I think this is spread over a few pages, so let's just change it to 2. There's an 8-page report now. So this is giving me some of the information on this particular part. And again, some of the numbers for the new design compared with the old design. So a really nice way of documenting, I guess, why we're changing the habit of a lifetime and not using polystyrene high impact. Okay, so a really nice report there. Okay, so we've had a look at how we can create a more environmentally friendly design. We're going to finish up on creating rendered images, so making photographic quality images there that you see on the left hand side. This is a great way of getting across an idea, showing the client what they're going to get before actually manufacturing a prototype. So it's a great way of creating things like colorways, for example, and things like that. So let's have a look at how we actually get on and do something like that. So back over in SolidWorks, all I'm going to do is come back over to my back panel. We're just going to make an assembly out of this because I want to add obviously the cans of Coke and things like that. So we're just going to drop in the back panel into a brand new assembly. Then I'm just going to start adding some components. So first of all, I'm just going to drag across like a pack of Coke that you see here. And I'm just going to spin those cans of Coke around and just center those up as well. And then just by eye, I'm just going to do this just to drag them roughly to where I want them, something like that. Then I'm just going to drop in that Coke badge that we've just evaluated. So let's just drop that onto the front of the shelf there. Then I can actually use what we call mates to start locating things. So I can say that that hole there, for example, I want to mate it up to the little pimple on the back, the little pip. And then if I just move that around, so you can see now that it rotates around that first pip. And then I'm just going to specify that I want those two to be concentrically mated as well. And that's my badge located. So I want to do the same down here. Again, I can use my linear pattern. So this time it's called a component pattern because we're going to pattern components as opposed to features. And I'm just going to specify that I want to pattern my cans of Coke and my badge. And we're just going to say that I want that to be 170 mil. I just want 2 of them, so we can just have a pack down the bottom there as well that you can see. And then finally, I just want to place a Coca-Cola logo on this top section of the back panel. So if I just zoom in a bit, I can come over here, I can add a decal. So we've got a series of decals that are already in here. I'm just going to drag across any, it doesn't matter, like this barcode, for example, whatever. And then I'm just going to browse for a different file. So I'm just going to now look in my folder that has my Coca-Cola logo in it. So you can see here that it's there. I'm just going to then use what we call a selective color mask just to pick out the red because I don't want it to show anything that was red in that graphic, just the white. And then I'm just going to scale it so you can see really, really simple to do this. Just going to scale that to roughly where I want it. Then we just shove it over there somewhere. That looks quite nice. And then that's my logo attached to it as well. Next thing I want to do is to apply some perspective. So before, perspective, as you can see, hasn't been added to this. So it just looks a bit strange. If I add perspective, you can see what it does. It makes a whole world of difference. So if you're going to render stuff, always apply perspective because that's the difference between having perspective and not having perspective. So it just looks a bit odd. So I'm going to apply a perspective. You can see here we've got a nice reflective background down at the bottom. We've got a series of backdrops that we can use. So you can see here we've got plain white, we've got some studio environments. I can drop this into a courtyard, for example, or into kitchen, or into like a Miami Vice setting. We're not going to do that. We're going to leave it just as it is at the moment, so just a 3-point standard faded. Then I'm just going to make sure that we've got a light turned on. So over here I just need to turn on my render engine to begin with, so PhotoView 360. Under here I'm just going to make sure that I've got at least one of the lights on, and then we can simply go ahead and create a preview. So this isn't actually creating the finished render, this is just creating the preview itself. So it takes a while, it starts out a bit rough, but hopefully you can see there that it's just getting sharper and sharper, and the longer I leave it, the better it's going to get. But this is a great way for me just to make sure that I've got maybe the lighting is correct, or I've got shadows in the right place, for example, which they are because I'm using the studio lights. But it also allows me, because it's a preview, I can actually start moving this around as well, so I can zoom in and zoom out and rotate it. But I think I'm quite happy with that. So all I need to do then is just to create a final render. So once I'm happy with it, I can come over here, click on final render, and that's then going to go ahead and render it out. Now I can obviously go ahead and change the resolution that I'm using, how big I want the image to be as well. And you can see here that pretty quickly it goes ahead and creates me a lovely image. So each one of those squares that you can see going around like Pac-Man style, each one of those is a core of my processors. So I've got eight cores here, so it does it fairly quickly. So if you've got a decent processor, it'll do it really, really quickly. And that's it done. That's my finished image. So let's just go ahead and save that onto my desktop. And if we just go and have a quick look at that, you can see my rendered image there. So really, really quick. Shadows and things. Looks really, really nice. Okay, so that was how to create rendered images. So just to recap then, SolidWorks. It's a great way of being able to create simple parametric parts. So that's being able to create things that are related to each other. For example, if I'm moving shelves, then things that are on it go with it, for example. So that's just building in relations, I guess, between certain parts. We can also use library features and parts. So if we're doing the same kind of thing, like for example, I guess in point of sale, like the Euro hook slot, things like that. If you're doing that time and time again, then we can save that as what we call a library feature. So in AutoCAD, if you're using AutoCAD, that would be like a block. We've got that, but they're generally kind of 3D blocks. We can also then create drawings really, really quickly. You saw how simple it was to create things like section views and detail views. Looking at material selections, so in our database, we've got a huge selection of materials that you can use not only to evaluate things like density, but also to do some stress testing on it as well. We've got the ability to do some sustainability studies, again asking SolidWorks to maybe find some parts that might be better, materials that might be more suitable and also cheaper. We can also create cut lists, so that is things like our flat panels. So you could see that we're able to flatten our sheet metal parts. If you're doing anything with box section or profiles, we can create things called cut lengths. So that's going to give us a length of the profile that we're using. We can also use SolidWorks to evaluate the weights and calculations as well, looking at centers of gravity, for example. We can also do stress analysis, and we can also create photorealistic images using PhotoView 360. That's our render engine. So why choose SolidWorks? Well, currently 2.5 million users we have across 186,000 companies within lots and lots of countries. So it's a really, really prevalent #1 CAD system. Why choose Cadtek? Well, you can only buy SolidWorks through a series of authorized resellers, Cadtek being one of them. Last year, we were ranked #1 for customer support satisfaction in Northern Europe. So if you did want to go down the SolidWorks route, why don't you come to Cadtek and we can help you along with that journey. If you want to see more, we actually hold nationwide seminars. So either you can use them on your own, you can actually have a go using a hands-on event, or you can just do the come along and watch at the seminar. If you want to get involved, give us a call, 01663 741 405, or give us an email, sales@cadtek.com. Thanks very much for your time.